What's up, y'all? Today we're going to be going over integrating factor again. We're going to be having an initial value this time, so we're going to be actually solving for c. If you remember the formula for that, it is 1 over mu of t times the integral of mu of t g of t dt. And we have to have our formula in a form like this to where we can actually you have to have a p of t that's in front of this, attached to this y. Here in this case it's -1, and then g of t has to be all in terms of t on the right side. So let's go ahead and define our values of g of t and mu of t. So our g of t is going to equal 2t e to the 2t. Our mu of t is going to equal e to the integral of -1 dt, which is -1 attached to this y. So our mu of t equals e to the negative t. So 1 over mu of t, 1 over e to the negative t, is 1 over e to the t, which is just e to the t. I like to think about it as having this, whatever this power is, the first term that goes before the integral, the sign is changed in the exponent. So we'll have y equals 1 over, so instead of doing 1 over, we'll just say e to the t times the integral, because it's 1 over e to the negative t, which is just equal to e to the t. So times the integral of mu of t, which is e to the negative t, times 2t e to the 2t dt. Now we can simplify this. E to the negative t times e to the 2t is e to the t. So y equals e to the t times the integral of 2t e to the t dt. So now that we have this, we can integrate, right? We just use integration by parts here. So u equals 2t, du equals 2 dt, dv equals e to the t, v equals e to the t still. So now we can integrate y e to the t times uv minus the integral of v du. And we're only worried about the plus c on the end of this. So y equals e to the t times 2t e to the t minus the integral of 2 e to the t is just 2 e to the t. And then remember your constant integration. So if you didn't have an initial value, this would be something close to your answer. You'd still have c in there, but we have an initial value, so we're looking to solve for this c. Let's go ahead and move this e to the power of t in, make it a little bit easier to solve. So 2t e to the 2t minus 2e to the 2t plus c e to the t. So this would be your general solution. We don't want a general solution though, because we have an initial value. So what we're going to do is we're going to see that y equals 1, x equals 0, or t equals 0, sorry, I said x, but you get the idea. So y equals 1, so we're plugging that in there, and we're plugging in for all values of t, we're plugging in 0. Well, this first one becomes 0 because 2 times 0 times e to the 2t is going to be 0. Minus 2e to the 2 times 0. So 2e to the 2 times 0 is going to equal 2, right? Because e to the 0 becomes 1. Oops. E to the 0 equals 1. So that's just going to be 2, and then plus c times e to the 0. Well, e to the 0 is 1, right? So we're just going to have c there. So c is going to equal 3, because we were going to add 2 on both sides. So once you have that value of c, all you do is come back down here and plug it in. Y equals 2t e to the 2t minus 2e to the 2t plus c e to the t. plus 3 e to the t. And this is going to be your answer. So let me get another problem ready for you. I got another problem for you here. So we have ty prime plus 4y equals t squared minus t plus 1. Our initial value is y of 1 equals 1 over 4. So this t in front is going to mess us up, right? You can't have a t out front and then define mu and g of t, because that's not how it works. So we're going to divide everything in this equation by t. So we'll be left with a y prime plus 4 over t times y equals t squared divided by t is just t, minus 1, t over t is just 1, plus 1 over t. And now we can define mu of t and g of t. G of t is really easy to define. It's just t minus 1 plus 1 over t. Mu of t is a little trickier. It is e to the integral of p of t. Our p of t value right here is 4 over t. So this is going to leave us with our mu of t equaling e to the times 4 natural log of t. 4 times the natural log of t is just equal to t natural log of t to the 4th, right? And when you're taking when you're exponent e to the power of natural log of something, that undoes it. So what we actually have here is u of t equals t to the 4th power. So now that we have that, we can go ahead and set up our integrating factor. Now, 1 over t to the 4th, y equals 1 over t to the 4th times the integral of mu of t, which is t to the 4th, times g of t, which is t minus 1 plus 1 over t dt. Okay, so now we can go ahead and distribute this t to the 4th to each term inside the integral, not like this in here, but you know what I mean, this like this. That would be totally illegal. So it's going to be t to the 5th minus t to the 4th plus t to the 3rd dt. And so once you've done this, you can integrate. Oops, I need the integral sign. So you'll have the integral of t to the 5th power is 1 over 6 t to the 6th minus the integral of t to the 4th power, which is 1 over 5 t to the 5th, plus the integral of t to the 3rd power, which is 1 over 4 t to the 4 plus c. So let's go ahead and distribute this t to the 4th, this 1 over t to the 4th power. Let's go ahead and distribute it over. So we're left with y equals 1 over 6 t squared, right? The 6 and the 4, only 2 are left over. Subtract them when you're dividing. 1 over 5 t plus 1 over 4 t over 4's cancel, and then plus c over t to the 4th. Now this is when we look at our initial value. We have y of 1 equals 1 of 4. So y equals 1 of 4, t equals 1. So this is going to be 1 over 1 over 6 minus 1 over 5 plus 1 over 4 plus c over 1. The 1 over 4's cancel. You're left with So yeah, these go away. You're left with 0 equals 1 over 6 minus 1 over 5 plus c. So this is going to give you, I believe, 1 over 30. 1 over 6 minus 1 over 5. Yeah, it's going to give you 1 over 30. Go ahead, just algebra. So I'm wrong, you can check it, but I don't think I am. So c equals 1 over 30. So now all we do is you just plug in 1 over 30 right here, right? So this is our general solution. We're going to change it from a general solution by plugging in that 1 over 30 that we solved for. So instead of this term, we're going to have 1 over 30 times t to the negative fourth power. T to the fourth power is in the denominator, t to the negative fourth power is the same thing, and that will be your answer. Yeah. Alright, so let's gear up for another one. So this one is going to be y prime plus 2 over ty equals cosine of 2t over t squared. And y of pi equals 0, while t is greater than 0. So now it's already in the form where we can define mu of t and g of t. I hope you can see that by now. This is p of t is a function that's out in front here, and then g of t is a function that's on the right. So mu of t equals e to the integral of p of t, which is 2 over t dt. G of t is going to equal cosine of 2t over t squared. Let's go back to mu of t real quick. So mu of t is going to be e to the 2 natural log of t. The integral of 2 over t is 2 natural log of t. That's going to be e to the natural log of t squared. So e to the t squared is just going to be t squared. So mu of t equals t squared. So now that we have g of t and mu of t, let's plug them in. So 1 over t squared times the integral of t squared times cosine of 2t over t squared dt. So that works out pretty nice, right? Because they cancel out. T squared times the integral of cosine of 2t dt. So cosine of 2t, how we're going to integrate that? It's just the same, you just do a u sub, right? So u equals 2t, du equals 2 dt, right? So then we have y equals, and then we'll have dt equals du over 2, so 1 over t squared times the integral of 1/2 cosine of u du. And what we can do from there is we will integrate this, right? Y equals 1 over t squared times the integral of 1/2 cosine of u is just going to be 1/2 the sine of u. Like that. And we know that u is 2t. Okay, so now that we have that, we can go ahead and distribute this t over. So it's looking like it's going to be 1 over 2 sine of, was it cosine of 2t or just cosine of t? Oh man, I copied on the problem wrong. Well, I copied on the problem wrong, but it's going to be, like the book is cosine of t over t squared. This is fine though. It's going to be, the answer's going to be right anyway. So it's going to be off by a factor of 2. 1/2 sine of 2t over t squared plus c in the numerator. Yeah. Okay. So now what we can do is we can plug in our y of pi. So sine of 2 pi is going to be 0, right? So we're going to have 1 over 2 times that do. That's how that's supposed to look. That's a little sloppy, sorry. So now we can do 1 over 2 times sine of pi, which is just going to be 0, so this term is going to go to 0. Y is equal to 0, so 0 equals 1 over 2 sine of t, so this is going to be 0, c over pi squared. So I think c is going to equal 0 here. Yeah, it does. Yeah, c equals 0 because when you plug this in and solve for c, it's going to be 0. So you're going to just be left with 1 over 2 sine of 2t over t squared, and that is going to be your answer. Alright, so I will erase this and be back with one more problem. Alright, we got our last integrating factor problem for you. It's an initial value problem. So we have ty prime plus t plus 1 times y equals t, which I'm going to make sure I copy the problem down right this time. I did. So y of natural log of 2 equals 1. That's our initial value right here. So we're going to divide everything by t, right? Because we can't have this t in front of the y prime. We have a function of t in front of y, which is fine. We have a function of t right here, which is fine. This is the problem. So let's go ahead and do that. Y prime plus t plus 1. You can do t plus 1 over t, or you could do 1 plus 1 over t. They're going to be the same thing. Because when you multiply this, or when you divide by t, you have this will turn into 1, this will turn into 1 over t. And this is going to equal 1. So our g of t is really simple. G of t equals 1. Mu of t is a little more complicated. Mu of t equals e to the integral of 1 plus 1 over t dt. Okay, so mu of t equals e to, well, the integral of this is e to the t plus the natural log of t, right? So we know that when the exponents are added right there, it's the same thing as saying mu of t equals e to the t times e to the natural log of t, right? E to the natural log of t is just t. So mu of t equals t e to the t. So now what we can do is we have our mu and we have our g of t. So let's go ahead and plug it into that formula, right? Y equals 1 over mu of t, 1 over t e to the t, times the integral of t e to the t, which is mu of t. And then our g of t is just 1, right? So we don't really have to put that in there. It's just an understood 1. Multiplying by 1 doesn't change anything. E to the t dt. So now we can use integration by parts. U equals t, dv equals e to the t, du equals dt, v equals e to the t. So y equals 1 over t e to the t times uv minus the integral of v du. So u v minus the integral of v du, which is just dt. So y equals 1 over t e to the t times, well, actually, oh yeah, I'm going to go ahead and write it out. I'm going to t e to the t minus, it's just going to be the integral of e to the t is just e to the power of t. And then don't forget that constant of integration on the end when you're finished integrating fully. So now we can multiply this 1 over t e to the t inside. So y equals, well, this is just going to turn into 1 minus, this is going to be 1 over t, because either the t's will cancel. And then this is going to be c over t e to the t. So now that we have that, we can try and solve for our values of c with our initial value. This is going to be our general solution. We have an initial value though. We want to find what c is going to be equal to. So let's do that really quick. And this is what it gets like, I guess, a little weird here because of that natural, like that's not very common, but it's really not that bad. So we'll see. So y is going to be our 1, right? We're using this equation. And our t is going to equal to natural log of 2, and then we just solve for c, right? It's just algebra at this point. 1 minus 1 over the natural log of 2 plus c over natural log of 2 times e to the natural log of 2. Okay, so now what we can do is we can say 1 equals 1 minus 1 over natural log of 2, and then plus c, e to the natural log of 2 is just 2. So this is going to be 2 natural log of 2 So if we have 2 natural log of 2, then what we can do is, well, I guess, yeah, let's go ahead and what is it, 2 natural log of 2, 2 natural log of 2, so this is going to be a natural log of 4, 2 squared. Basically these ones are going to cancel out, right? So we're going to have 0 equals negative 1 over the natural log of 2 plus c over the natural log of 4. You can get rid of, might have messed up somewhere, let me make sure. I found it. I didn't really make a mistake, I just gotta play with it for a second. So if you just keep this in terms of ln to the power of 2, you'd have ln 2 e to the ln of 2, right? And then it's going to be 0, you just multiply by ln of 2, you're left with 0 equals negative 1 plus c over 2, right? Yeah. And then you would add, you would add 1 over, 1 equals c over 2, and then multiply 2 over c equals 2. So your answer is going to be y equals 1 minus 1 over t plus 2 over t e to the power of t. Placing that at c with 2. So this is going to be probably all I'm going to do on this chapter, or on this section of integrating factors. I'm going to come back with you and I'm going to do, I think, probably section 2.3, which is, it deals with like tanks and like input, like rate in, rate out, and stuff like that. I'm going to figure out, I might have the problems written and copied into the description, maybe not because they're kind of long. I might just write them up here. We'll figure it out. But if you have any questions, just feel free to email at me, cosmothetutor@gmail.com, or just message me on YouTube. Thank you.